All right, we're recording. This sounded pretty easy. Should just be recording the distance that it's receded, right? In the different years.
Yeah, I sent you another document, shared Google document, but it didn't send it to you for some reason. I'm gonna send it. Okay. You should have it then.
There it is.
Ah! I kept coming back saying messenger error, could not send, address does not exist. Now it exists.
Huh. All right. So
you guys want me to do it? I can read.
Okay.
Read away, man.
So hungry, Emily. Okay. Is it okay if I read the instructions here? Okay. So using the historical satellite imagery, we can measure the changes in glaciers over time. As a group, using the images provided by NASA below, observe how much retreat has happened to the Hayden Glacier in Greenland since 2001. Use some of the features on the edges of the glacial valley to note the locations of the glacier margin in 2001, 21, 2003, and 2005. Use a place marker for the location of this glacier. Use Google Earth to estimate how much retreat has occurred over the past 14 years in kilometers. As a group, discuss possible reasons to explain this amount of retreat in such a short period of time. Okay, there we go. The images. Gonna open this place marker.
All right. I'm already sharing my screen.
Yeah.
Thank you.
So we've got 2001 back here, and 2005 over there. So from 2001 to 2005 in kilometers, roughly.
That's quite a bit for, I don't know how the textbook talks about average glacier rate.
Oh yeah, that's really far, really. I mean, so 8.18 about is what it's gone from 2001 to 2005. So, and we're also supposed to estimate. So in 4 years' time, it went 8 kilometers. So we're also supposed to estimate how far it's gone in the 14 years. So I guess like to date, or whatever that is, or close to it. So that would be. I mean, there'd be differences in every year, obviously, because you can tell even just on this that there's some years like from here to here. I mean, that's a huge difference. But then a lot of them, it's real narrow, real, you know. But then some are just leaps. But so if in 4 years it went 8 kilometers, 14 years, if it was roughly the same, it would be. Whoops. Dang it. So 28.63 kilometers, which that's a long ways.
So why?
Oops.
Why has it gone that far in a short period of time compared to others? Kind of one of the questions we're asked to debate.
Well, I think it's just that whole Earth's in a warming trend.
Mm-hmm.
So because we're slightly closer to the sun, right?
Mm-hmm.
I think also might be also moving laser. So it breaks, it gets brittle, and so as it breaks, it melts. I would say.
Is it on more slope than usual? Or is the surface smoother than like the average surface?
Wait, what was the question really again?
So the question is, why is it falling at the rate it is, basically? And I'm wondering if it's on more of a slope, like a steeper slope, or if it's on maybe smoother rock instead of
Oh, I don't know.
gravel or something that would cause friction, more friction. But we talked about crust and fluffy, so I guess even if it is smooth, it would still kind of flex the rock.
Well, I mean, it finds its little happy place. I think the biggest contributing factor is for it to recede or be going forward is just the amount of snow production. So if the snow production's been low,
There have been a lot of droughts this year.
You know something interesting. I think. You see that in the photo, there are dark areas than the others.
Mm-hmm.
So the darker areas they will absorb more heat than the wider ones. Consequently, that would melt fast.
Sorry, what did you say?
So in the darker areas of the glacier, I think that those darker areas absorb more heat. You know, like faster.
Absorb more heat?
Yeah, like darker color. You know, like dark, like black colors, for example.
Okay, yeah.
That doesn't reflect any light. That absorbs all of it. I don't know all of it, but a, a huge part of it. So I think that's kind of like the same with this. Like there are some darker areas, and that's gonna. So once it gets a little bit darker, it's gonna absorb more heat and reflect less light, and that's gonna increase the rate of melting, I would say. And then in that area, it's gonna be easier for other to expand and melt more and melt more. You know, our other nearby areas. I don't know if that makes sense. That
Yeah.
could be one of the things.
I can get behind that.
Mhm.
I mean, I think from our readings, it's sort of with the warming trends. Aren't we going to be in a warming trend for like more than 100 years or something? It's something that's like quite a while, so it's only going to get warmer.
Mm-hmm.
I'm trying to remember from the reading because it did say that specifically, but
Yeah, it's going to be a while if I remember that correctly. I mean, not a while compared to geologic time, but a while compared to our time.
yeah.
Mm-hmm.
We won't see it in our lifetimes turn the corner going to cooling trend, that's for sure.
Yeah.
Yeah.
So I like that of us being in the warming trend. My only question is, if we are in the warming trend, wouldn't that influence all the glaciers? Whereas others are still going at a much slower rate, according to the textbook, and this one is going faster.
Mm-hmm.
Yeah, I mean, I would imagine all of them are, but maybe it is that one is faster than most or something.
Yeah. I wonder what would be the factor that makes it melt faster than the other ones. Because I mean, all of them are gonna start melting, but there's something about this one that makes it different and special. That's Google.
Mm-hmm. This is in Greenland.
Well, I mean, we can look at real quick on mine. So even just a few of these other ones that are closer.
Oh
Like
yeah.
this one doesn't look like it's changed a whole lot. Like it looks like it's not changed very much at all. But this one in 2001, and let's see if this is even that's 2010. So from 2001 to 2010, it's only gone that far, which would be that one's only 1.78 kilometers.
Mm-hmm.
But I mean,
The dimensions are a bit smaller. Do you think that has something to do with it?
yeah, I mean, it could definitely influence it. I mean, this one looks like it should be almost like it's being fed from a really large area, but maybe what's feeding it is lower in general, so it doesn't actually get as much snow. Whereas if this one is coming from higher mountains and stuff like that, possibly, then maybe it just gets more snow, and so that's why it hasn't receded as much. I mean, this guy over here, let's see. That's 2000, 1981. 2000, and this one up here is 2010. So this one's going to be more too. So this one from 2000 to 2010 is only about 9.5. So that other one is still considerably more. But that still is based off of our just guesstimating off of 2001 to 2005.
It was in Greenland. Maybe it has a lot of volcanic activity around it that maybe through earthquakes or through just the heat coming from the earth makes it a little faster.
Yeah. I'm sure there's a bunch of different reasons. But even just looking at it's hard when it's all snow covered and stuff like that. But dude, this is what's hard. So right here, dead center, this is showing like at some point 2010, 2011, it was back to here. So that's confusing.
So I'm struggling with understanding this map, like these lines here. So each line is a year, but if it's retreating, to which side is it retreating? Oh, to the right or to the left, like on the screen?
So it's receding going to the left because if you look to the right here, so this is where it's all melting next to the ocean.
Yeah.
So if it's receding, it's going to the left, further this direction.
Okay, so it's melting here and continues to melt going to the left direction.
Yeah, but I think
That
so.
would
As
be
we
east,
click,
right?
yeah, east. No, that would be it's receding to the west, from east to west.
West. Okay. That's
The
fine.
west. It's the west.
So, but like I was saying, so in here though, I think this one changes a lot because down in the center here, there's some 2011s where it's from 2005 to 2011 and actually grew. What's the word?
Gained.
There's a real term for it for the glacier. Anyways, so
And what does
yeah. I don't know if we want to say that it is 28 because that's showing like it's sort of it goes back and forth. So
for example,
it hasn't been consistently receding. If that makes sense.
so this one, for example, what does it look like right now? If we go to 2017, does it have that?
I don't think so
Mm.
because this should have, unless all these are different. So this one just has a bunch of different measurements, but yeah.
Mm-hmm.
So, but you can see, so on the right-hand side was 2001. So it did recede all the way back to 2005, but then it did gain. Got to figure out the other word. I know there's a better word for that, but it did gain. At 2010 and 2011, it was quite a bit further.
Mhm.
So from 2005 to 2010, it actually gained 3.3 kilometers. If I'm understanding this right, if you guys,
So it gained? Wow.
yeah.
So that's
So you
5.
can see the date. That's 2005. So in here, 2010. So it gained. So over on the furthest right hand side is 2001, 2005 all the way over here,
Mm.
and then at 2010 it's back to here in the middle.
Wow.
Hmm. Interesting.
So I mean that just says that it is probably heavily influenced by snow production,
And
and there's just better years than others, and it's getting warmer, but it just depends upon the year.
mhm. I also think about, I don't know if this could be it. So there's a huge mass of snow. If we go to the left, right, there's a huge place. Um,
Yep.
so maybe like in some warm seasons, that it started to melt, became like water in the liquid state. Maybe if there's a slope, it went down the slope, and it went down the slope and went down until then we got to the colder season, and then it kind of solidified again. And then on top of that, we had the snow, and that's how it might have been expanded to. Might have gained some area coming from west to east. Because it's interesting how it gained 3 kilometers and something, right? But I don't know if that, besides the snow gain, that could be something.
Yeah. I mean, I think once water melts, though, it's gonna it's gonna go to the base, so it's gonna go to the ocean. It's gonna find its way there before it actually has a chance to really freeze.
Mm-hmm.
But I know that underneath, the groundwater will get under a glacier, and that's what helps make it slide.
Mm-hmm.
But anyways.
So is this on top of or like coming from an ice cap?
From the looks of it, to me, it looks like more of a ice sheet because it just looks like flat land rather than. I mean, just all this. This just seems like an ice sheet, but.
Oh, I thought that was the computer just blanking out and not showing the data. I didn't realize that was all just ice.
Yeah.
Yeah, I don't know. I mean, it is weird because it's like this. I don't know why it's like this seems all high definition, but then you can still see like there's some like. Anyways, I don't know.
Guys, do you think that when we get closer to the ice sheet, the rate of retreat decreases because I guess the temperature around that is is lower than the further areas. Hello.
Sounds great, Rashawn.
Oh yeah. Yeah. So do you think that the rate of retreat decreases as we get closer to the snow, to the ice sheet here?
Yeah,
Maybe.
that would make sense. I mean, I'm still unsure about. I don't know if this is like showing us Greenland like in the moment or in its deepest winter,
Mm-hmm.
Here, let me look up Greenland on mine and I'll share my screen so you can see
Is there
it.
like is there a temperature feature for us to see temperatures and things like that? I think there is one. Actually, let's see.
Yeah, there's weather. If you go down to layers, you can add weather.
Weather.
Yeah. That just adds clouds.
That just adds clouds. Nice.
Oh yeah.
Let's just make sure we can't see nothing.
Yeah.
I mean, I'm willing to bet that obviously in the winter, this is what Greenland looks like.
Well, this is today. It's still pretty snowy.
Oh, guys, you know what is really cool? If you go to the tab called Global Awareness under Layers and you clicked on it, it's gonna pop up a little icon by the Hamlin Glacier, and it's gonna give you really cool information.
Where is the? That's not the right one.
So under Layers, there's the one that's I think it's
Got
already.
it.
That's cool.
Layers?
So after years of moving at a relatively stable speed, Helheim Glacier in southern Greenland has dramatically accelerated. According to the University of California, Santa Cruz study, the glacier's peak rate of flow has increased from 8 kilometers per year in 2000 to 11 kilometers per year in 2005. In addition to flowing more rapidly, the glacier thinned by 40 meters between 2001 and 2003. The Calvin front of the glacier, the area where the ice breaks away from the ocean, has retreated by approximately 5 kilometers. According to the authors of the study, the likely underlying cause of these changes is higher air and water temperatures in the area of southern Greenland. However, the study also identifies a relationship between the retreating front of outlet glaciers such as held high into the increase in the rate of flow. As the front of the glacier retreats, it offers less resistance to the glacier's movement. Yeah, it's nice.
Ah, so we got a combination of temperature and movement and makes the ice break, and that's kind of escalating.
Mm-hmm.
And also, when it breaks, it increases the surface of it, so it will melt faster.
So it's kind of a mixture of what you were saying, Jershawn, and a little bit of what you're saying, Ben, about the different temperatures at different places and different times, and as it's going down, the water underneath will like lubricate it, and then that makes it fall faster, which causes more friction, which causes kinetic energy, which causes heat, which makes it melt faster, more water, which et cetera, et cetera, et cetera.
Yeah,
Kind of increases.
that was a beautiful summarize, Emily. Good. Good, yeah. I think that's true.
Mm-hmm. Mm-hmm.
Density and retreat.
What does it look like compared to your picture? See if I can like. Sorry, pressing too many buttons. Too many buttons. Okay. 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 Ready this.
Hmm.
I'm gonna take a tool. People side by side. Okay. Then I will. Alright. So then, Ben, you wanted to share your screen again, then we can look at the Google Doc picture and your picture of what it was. Then see if anything changed.
Sure.
It's gonna be hard with the tools, but
Oh, amen. I don't know how it fits, but they look
it
the same.
looks like it looks longer a little bit.
It's hard to tell with the difference in the edges and how it's melting here.
We have like 15 more minutes to fill before we're at our 45 minimum.
It's 45 the minimum? I thought it was 30.
Nope,
Oh.
it's 45 to 60. I figured that out last week when we ended, and I was like, wow, that's fast. And then I went back, and I was like, oh, it's 45 minutes. So we
Wow.
hopefully it doesn't affect our grade too much. But.
Guys, while you guys are talking, look at this rock. Do you guys recognize this rock?
It's dark and shiny.
Yeah. An igneous rock, the obsidian. We went on a field trip just for the day. And we went to a place and we collected this. Well, we looked at different rocks and mountains, and we collected this sample. It's beautiful. And then
cool.
the Native Americans would use this for hunting and tools and things like that. They're pretty sharpy sometimes.
So is it relatively soft? Most Native Americans would get soft rock because then they could like, form it easier into a sphere shape.
Yeah, that's what I think. And it's beautiful. It's an obsidian rock. Very glassy.
You know what tribe of Native Americans they were talking about?
What was that, sorry?
Do you know what tribe of Native Americans they were talking about? Sorry, I'm archaeology.
Oh, no, I don't know. I just know that they used it for hunting. But I don't know which tribe is it. Guys, I think I forgot my phone in the next door room here. I'll be back in 1 minute. I'll just check because I think I left it there real quick.
Okay. So what was something interesting you found this week?
It's interesting. Jershon has a much more interesting life than I do with rocks.
Mm-hmm.
I haven't found anything that interesting, but I did. So from a few weeks ago, if you remember my GeoJournal where I posted the slabs and stuff like that.
What slabs? There's been a lot of slabs of rocks.
Well, I'm saying like I was posting about because we were looking at slabs for the rental house.
Oh yeah, now I remember.
So I was actually pretty surprised because when we went back the second time, I looked at those crazy ones again, and they actually had it listed correctly as it wasn't just listed as quartz; it was actually listed as quartzite. I was sort of impressed.
Did I miss something in the lessons between quartz and quartzite? I was like, yeah, that's interesting, but I have no idea really what that means.
Well, I thought it was the quartzite was just that it had gone under even more pressure and stuff like that, and so it's even more metamorphic. Like, because at first I thought they were listing them as granite slabs. Anyways, so there's a difference.
Quartz and quartz. Right. Let's see what Google has to say about that.
Emily doesn't believe me.
Maybe. Okay, so the two common top materials that have grown quartz used to be known as engineered stone, just as material that's made it. Whoa. But quartzite, by comparison, is a metamorphic rock. And if you get quartz, basically fake. But if you get quartzite, it's the real deal. That's good to know.
Found it. Yeah. It was plugged in. It was charging in a different room. There you go.
We just retaught ourselves. There is a difference in quartz and quartzite.
Oh wow. The quartzite is the metamorphic, right?
See, look, Trishan knows more than everybody.
No, guys, you know what? I just got out of a test just right before talking to you, and we were quizzed on all the minerals, sedimentary, metamorphic, and igneous rocks, about 80 samples, and we needed to memorize all of them. So I just finished the test, so it's kind of like fresh. It's still fresh.
You're gonna be so much
It was crazy, but well, I think I did relatively well, so I think it's good. But I still need to practice more.
How was your field trip with the lab? And then you did the geology, you did rock stuff.
How was the what? The 4th of July?
No, a while ago you did a field trip with your geology lab.
Yeah, it was. I kind of heard what you said, but I think you asked about my field trip. But yeah, it was a field trip for the geo class. So we had like a field trip 3 weeks ago, and that was like an overnight field trip. And we went down to, well, we first went to Wyoming, visited a few places there, and then we went all the way down to Utah, and then we visited. Now we stayed camping in the mountains, looking at the rocks. It was really nice. And then last week we did this short field trip during lab time, and that was we went to the Snake River here in Idaho, look at some mountains and some river stream patterns. We collected some samples, and yeah, it was fun. Sometimes I feel really lost sometimes because it's like speaking Chinese to me, but little by little I'm getting the hang of it. You know, learning the concepts, and it's cool to be able to see it right there. So that helps.
Nice.
Have you guys visited the Grand Canyon one time, like ever?
Once.
Yeah. I want to go there one day. I've never been there.
It's pretty cool. Honestly, you can see a lot of the same stuff as Zion's National Park.
Mm-hmm.
Grand Canyon is much larger scale.
Wow, that's really cool. So basically, that's well, sedimentary rocks, and is it the sandstone? I guess, right?
Yeah. So.
Wait,
When I was like the Grand Canyon looks like it's mainly white, but because it's so big, it has a lot of heavy interesting to go see and be able to see. On my phone and just like, do you journal?
Mm-hmm.
Did you think it was hilarious? I laughed so hard.
At the end part?
Yeah.
On yours?
Yeah.
I'm going to look it up right now.
Okay.
Because I did read it and I thought it was funny. But I now want to refresh it. Let's. So just FYI, I looked at our grades. All of our group activities, we've gotten really good scores on. Was it last week that we ended really short? Or what week was it?
Last week we did 30 minutes, 45 minutes.
I don't know why I had in my mind it was 30, but yeah, it's 45.
I thought it was 30. So nothing.
Yeah, I think because our very first group activity was the one that we got the worst score at, and that one was short, and it didn't seem that. I guess we didn't have good enough conversation. But
Sure. Don't know what else to think. Glacier. I know to go in for a few more minutes, and I want to construct. But I think there's really any other possibility.
The only ice cream shop for geologists.
Yeah.
Nice.
Thank you. My friend was here, she was upstairs, and I had to like run upstairs and be like, oh, stop! And I ran upstairs and
That's funny.
We just have one more test to go, right? One more exam, the final one.
I think we have like a prep review, and then we have 2 more.
Yeah, so it's gonna be one over the next 3 weeks. The last 3 weeks and then one final.
Oh, okay, 2 more.
Which is probably gonna be brutal.
I think
everything.
Hopefully we'll focus more on the last weeks. Well, the first weeks are not.
But I figured out. If you go to the master section, you know how you can look at numbers and pick a test you need to do, and open up the. There's also one there and like review.
You can review. You can. What was that? You can review the quizzes.
I don't know. I'll show you. Let me pull it up.
Cool.
I think the first exam I did there, it's preparation quizzes, and they were sort of junk. I was like acing them. Felt really good, and then took the exam, and that's when I got a C.
So was it the model? You can click on it, and then it opens up in a minute. Okay.
Oh, right.
And so you can do like intro, stage tectonics, or like a gust of and then sorry. So that you.
So how do you get to that tab one more time?
Okay, so go just to your opening that's from geology.
Mm-hmm.
So here you can like click on this one, you can click on score, you can click on the text, and then after, like on the bottom part, dynamic.
Oh, dynamic stat. Oh.
Yeah. This is what you did.
I didn't know that trick. That's very useful.
And it shows you how long it takes you to do it.
So it will basically quiz you on the same questions or very similar ones to the ones that we've already done.
Probably. Yeah.
Well,
And then-
like I was saying, I did those for that first exam, and the questions are
Different.
they're very not related.
I think it's still very wise to keep record of the questions during the quizzes and study from those and from the book.
I mean, all review is good. I was just surprised because I was pretty much destroying these prep quizzes, what they were titled when I didn't update.
Mm-hmm.
So do you also area?
Say that again.
So click on study area. And it pops
Yeah.
up, and you can read the videos, animations, tutorials. And this field is very helpful. But like
Ah.
Let's-
I find it funny the most worried sounding out of all of us, that you're like bibliography, geojournal, era. Sorry. I find it the fact that you're really worried.
Yeah, hopefully the final is not too crazy.
Mm.
But it is a long time since we studied rocks.
That is true.
And tectonic.
review.
Stuff like that.
I know, but all the different types, like the layers and the felsic and all that, just haven't that really struggled with.
Yeah, that's a good memorizing. It's cool. I live in the Bronx, and it's nice to walk. I know that rock.
That is cool.
Mm-hmm.
On my drive for the high adventure trip, I was close to the Grand Canyon, and so I was seeing all these layers. And all this. So cool.
That is really cool.
I wanted to stop and take a picture, but we didn't.
Yeah.
Because there was even some that was lining up with what we had just studied, where the layers had been propped up and then cut off by weathering and stuff like that, and then new layers come up on top of them. So it was like, and then layers up like this. So it's really cool.
Mm-hmm.
All right, I think we've hit our mark since we've sort of just been dilly-dallying.
Yeah. I think we went through everything. I'm gonna get the geojournal done completely.
You better, man. We need somebody to respond to.
Yeah. All right, my friend. Well,